In this video, we will be looking at how to prove two lines are parallel. Okay, so you might, for example, have two lines like these, and then you need to prove that they are parallel. The question is, how would you do that? Now, do you remember the fun angles and parallel lines? We remember that the F is for corresponding angles. And so if you can prove that two angles are corresponding, then naturally the lines must be parallel. So you could prove that, or you could prove co-interior angles. Remember, where if we add those angles, we should get 180 degrees. So this is proof that two angles are co-interior or supplementary. And the third way we could prove this is by saying, okay, if I have two alternate angles that are equal, then it must be that these lines are parallel. Okay, the only note that I want to make is that if there is an x, okay, an unknown, if there is an x or any unknown, you first need to solve for x. And then the second step, and don't forget this, is to substitute x back into the diagram. Okay. Now let's look at what I actually mean. In this question, we will need to answer why are lines AB and CD in the diagram parallel. So there's line AB, there's line CD. The only thing they give us is an angle of 108 degrees and 108 degrees. So get your highlighter, take it out. Do you see that there's a shape forming a letter even? It's an upside down F. So what does that tell you? Since these angles are equal, we can say that because of the corresponding angles, the lines are then parallel. Okay, so you need to look at, you need to look for parallel FU or N angles. Okay, let's look at the second example. The line AB is given, CD, we need to prove that they are parallel, and the only other thing they give you is angle G4 is 77 and H2 is 77. Okay, so G4 is equal then to H2. We see this because they are both 77 degrees. Now, because this is the case, do you also see, maybe do you notice a letter? I can see the N or the Z forming, and thus these are alternate angles. And because the alternate angles are equal, we can say that is the reason for line AB and CD to be parallel. Okay. So this is just a basic example. You will have to look for angles that are equal. Let's do a more challenging one where there is also an x involved. So the question is, prove that line PQ is parallel to ST. Remember our steps. You look for these types of angles. If there is an x though, you need to first solve for x and substitute x back in. Okay, let's go for it. We see that there is an x and there. What else do you notice about this angle here, this angle O? These two are angles on a straight line. Okay, so if I add them, they should give me 180 degrees. So let's write that down. It's our first step. We solve for x, our unknown. Okay, so I'm going to say the 4x plus 30, that's the one angle, plus the 3x plus 10, and that's the other angle, should give me 180 degrees. The reason we already said, angles on a straight line. Okay. Now it's a simple equation. I need to isolate the x, so let's add the x's together. You get 7x. Let's then add the whole numbers, 30 plus 10, that gives you 40. And on the other side, I still have 180. We're still looking to isolate x. We still want that x alone. So let's take the 40 to the other side. And we're going to say 180 minus 40. And we're still left with 7x. Okay, 180 minus 40 is 140. I have 7x. How do I now isolate the x here? I get rid of the 7 by dividing it, because that's the opposite of times. And if I say divide on the other side as well, 140 divided by 7, your answer is 20 degrees. So remember, my first step taught me to solve for x. Now my second step would be to substitute x back in. If I substitute it in for this angle, which is called SOR, I see that it's 4x plus 30. In the place of x, you can write 20, because that's what we found x to be. Put that in your calculator, and that gives you 110 degrees. Then let's sub it in for this angle, which is called SOM. Okay, let's sub it back in. SOM, and it's 3x plus 20. If I sub the 20 degrees for x, I find that my answer is 70 degrees. I actually need to go and write that in on my sketch. Okay, let's indicate that on your sketch. This angle is 70 degrees, this one is 110, because you need to see something. And what you can see here, two things. We have a U forming, so that's co-interior angles, because 110 plus 70 gives you 180. Okay, so that's one possibility. We also see an F forming. There's the F. And I see this because the 70 there is equal to the 70 there. So I have two options to prove that these lines are parallel. Let's go with any choice. Let's go with the U option. Okay, 110 plus 70 gives me 180. How am I going to write that down? First, I name the angle. The 71 is PNO, angle PNO, that's 70 degrees, plus the other angle SOR, that's the one that is 110 degrees. I add them and I find that the answer is 180. Now I can say, because of that, PQ is parallel to ST, and the reason is what I just proved. Co-interior angles are supplementary, which means together they are 180 degrees. Okay. Now you might be wondering, this is just a little extra by the way, you might be wondering, how do I solve x? And in this case, you need to use all your theorems that you learned in grade 8 and 9. Remember that you have angles on a straight line. Okay, so two angles, when you add them together, they should give you 180 degrees. You can use that. Then you also have angles around a point. This guy is for revolutions. Remember the angle that all of it adds up to 360 degrees. You could also use vertically opposite angles. We know what they look like. So it's angles when they look at each other, they are exactly the same. If somehow there is a triangle, okay, like in the very last example, there's a triangle and they want you to prove that two lines, like these ones, are parallel. What will you do then? Remember your theorems. Firstly, we know that angles opposite equal sides from an isosceles triangle. You could use that. You could use the sum of the interior angles in a triangle. We know that if you add the sum of the angles, it gives you 180. You could use the exterior angle of a triangle. If you remember, the exterior angle of a triangle is equal to the two opposite interior ones. Finally, you could use the theorem on equilateral triangles. Equilateral triangles, you remember that all three angles are 60 degrees. Okay, so this is a little cheat sheet and a summary for you. How can you solve x using one of your theorems? Now, on to the last example. What they ask you is to prove MN is parallel to OP. Let's go and find MN. There is MN and it's parallel to OP. You are given that S1 is Y, S2 is X, and Q1 is 60 degrees. Since you have a Y and an X, we remember that our first steps are to solve X and Y. I am going to start with X since it's the first letter in the alphabet. Okay, let's try and look for a way to find X. Use one of your theorems here. Okay, think about it. X is on the outside of the triangle. So if I grab my highlighter, I see that X is the exterior angle, and I can add 40 and 80 degrees to give me that X. Okay, let's write it down with a reason. So we would say something like X is equal to 40 plus 80 degrees, and the reason is exterior angle of a triangle. When you add that, you find 120 degrees. Now I go and I sub that back in, or just write it down at least. This is 120 degrees on my diagram. Next, I find Y. Okay, since you've already found X, just look next to it. Always just look next to it, or on top or below, and you'll see that Y and X together form a straight line. And if I add these two angles, they should give me 180 degrees. Okay, cool. So let's write it down. If I want to find Y, I need to add Y and X together. They'll give me 180 degrees. Angles on a straight line is the reason. And Y, we're looking for X. We found in the previous answer, it's 120 degrees. Together, they give you 180. If I want to isolate Y, I need to take the 120 over, and I need to subtract it to take it to the other side. I'm left with 60 degrees. Let's go write it back in on our diagram. Okay, I still haven't proven anything. The question was, prove that line MN is parallel to OP. There's MN and there is OP. Do you notice though that there's a 60 and there is another 60? Okay, do you see that? So do you see a pattern maybe? Let me get my highlighter. I see that two angles that are alternate are equal. And therefore I know that these lines are parallel. So let's write that down. I see that Q1 is equal to S1, and both of them are 60 degrees. I've just proven that. Thus, MN is parallel to OP, and the reason is alternate angles are equal in this case. Alright, thanks for watching. Remember to share, like, and subscribe.